Hello, today we're going to be looking at lesson 89, and it is about analyzing, prisms. Now this is another one of those lessons where we're going to look at it on a video just a little bit, and then we'll actually play with those wooden shapes again tomorrow just to make sure you're understanding everything. But we're going to take a look at a couple concepts, a couple pictures, and then we'll play around with it a little bit more tomorrow. All right, the three facts that we're going to be taking a look at today when we are looking at prisms is number one, it is a prism is a three-dimensional solid. Now, we've talked about three-dimensional. That means it has height, it has width, and it has depth. It is not one-dimensional, where like it's a dot. It's not two-dimensional, like you would draw just a plain triangle. So that would be one-dimensional. This would be two-dimensional. And then, like we did last time, we did work a little bit with three-dimensionals, where you can see that there is depth to it. So a prism is a three-dimensional solid. So that's the first fact to remember. The second fact that you need to know about prisms is number two. The bases are parallel. Whoops, sorry about that. Are parallel and congruent. Now, we've just talked yesterday about congruent, same shape, same size, must be both, same shape and same size. So when we say that the bases must be parallel, you remember what that means as far as they aren't going to run into each other, and congruent. So prisms are a three-dimensional solid. The bases are going to be parallel and congruent. And the third fact is the name of the prism comes from the base. And we'll put comes from the shape of the base. The name for the prism comes from the shape of the base. Now, I've told you many times before, I am not an artist, so I am not even going to begin to try to draw these. I'm going to take a picture, put it up, and we'll take a look at them together. And again, then we'll play with the little wooden shapes tomorrow. Okay, now that I haven't had to draw them, I'm happy, but you will still be able to see what we're talking about. Now, let's take a look at A, the triangular prism. If you will notice right here is a triangle. Over here is the parallel triangle. Remember, they must be parallel and congruent. So that is showing you that that's a triangular prism. It's got the bases that are parallel and congruent, and it is a three-dimensional solid. So what they're showing you, you'll notice there's these little hashtags or hash marks on there. Those are showing you same size. We have done that before when we've been drawing triangles. So it's easy to see that because the base is a triangle, it is called a triangular prism. Now, just a reminder, we've talked about vertices and edges before. The vertices are where they meet. So 1, 2, 3, back here would be 4, 5, 6 vertices, and the edges are 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, 6 vertices and 9 edges. Vertices are where the edges meet. Again, its name comes from the triangle. Now, if we're going to look here at the next one at B, well, this shape right here is a rectangle. You can tell it's a rectangle because these marks show they are all the same length, size. And it's a triangular prism because it has bases that are congruent and parallel. And again, we could count up our vertices and edges. We won't because you understand how those go. Here again, another shape is our trapezoidal prism. Trapezoid. These two are are equal in length. But notice they are not parallel because they would, if it continued, run into each other. They are, however, parallel to each other. This side right here is never going to run into this side right here. So that's why we would say they are parallel and congruent bases. It's a trapezoid shape, which we've talked about before, has one pair of parallel lines, which in this case, this line right here and this line right here are your parallel lines and a set of non-parallel lines. So that would be a trapezoidal prism. Now let's take a look down here just at the hexagonal prism because I think it's easy. It'll be easy to see everything. When we look at the vertices, we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So hopefully you saw all 12 of those vertices. And then when we move to edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So again, vertices are where your edges meet. So hopefully that makes it a little clear. Again, this one we call the hexagonal prism because this shape down here is a hexagon. And this shape over here, which I can't even trace very well, let alone draw, is also a prism. Is also a hexagon. So I hope those ideas are making sense to you. We will play a little bit more with these with our little wooden shapes tomorrow and look and see, which ones have congruent sides, which ones are congruent. Like for example, this would have, let me get a different color real quickly here. This right here would have a congruent side of 1, 2, 3, 4 congruent sides because they are all the same size and the same shape. So here we would, down at the pentagonal prism, 1 and then 2 over on the back, 3, 4, 5 congruent sides. So we'll be looking at things like that tomorrow. Just so long as you have a basic reminder of prisms are three-dimensional solids. They have parallel and congruent bases, and their names come from the shape of the base. So hopefully that makes sense, and we'll play with it a little bit more tomorrow in class. Have a wonderful evening.